Hello. Okay, this is my science project. First I'm going to be demonstrating Newton's first law, which is an object in motion stays in motion, or an object in rest stays at rest unless acted upon by net force. Right now I'm going to show that a rock, when thrown, will stay in motion until acted upon by net force. In this case, the net force is gravity. So, there we go. There we go. It hit the ground, and that is gravity. I'm going to be demonstrating Newton's first law once again by showing that an object at rest stays at rest by pulling a pillowcase out from under two books, and they will stay at rest, and this demonstrates it because they are staying at rest. Okay, now I'm going to be doing my final example of Newton's first law by showing that an object at rest stays at rest and an object in motion stays in motion until acted upon by a net force. I'm going to be showing this cup, and it's staying at rest right now until acted upon by net force. I'm going to knock it off, and it stayed in motion until it hit the ground, and that was the net force, and now it is staying at rest. So now I'm going to be demonstrating Newton's second law, which is that force is directly proportional to acceleration and mass is inversely proportional. So the more force is applied, the more acceleration there is. The more mass there is, the less acceleration there is. So now I'm going to demonstrate that by pushing my brother. And so I'm going to push him with a little bit of force, and then I'll push him with a lot of force and show how he accelerates. So first, I'm going to push him with a little bit of force. He doesn't move that much. And I'm going to push him with a lot of force now. And he accelerated. I'm going to be demonstrating Newton's second law once again. I will be showing that the more mass there is, the less acceleration there will be, even when the same amount of force is applied to it. So I will show that this works because my brother is pushing on the fridge, and he's using a lot of force, and it's not accelerating. The fridge has a lot of mass. And then when he when he pushes the empty box with the same amount of force, it accelerates a lot more because it has a lot less mass. For the final example of Newton's second law, I'm going to be showing that the more force is applied, the less the object will accelerate. The more the object will accelerate, and the less force is applied, the less the object will accelerate. So I'm showing this directly proportional. And I'm going to show this with my nunchucks. So when I apply only a little bit of force, they don't go that quickly, and it's not much power in that strike whatsoever. And then when I apply a lot of force, it accelerates a lot quicker, and it has a lot more power. And those accelerated a lot faster and even made it whoosh as they cut the air. So I'm going to be showing Newton's third law, which is for every action there is an equal and opposite reaction, and I'm going to be showing this with a bouncy ball. So my brother's going to bounce the bouncy ball, and the same amount of force he applies to it going downward will return the ball upward. So when he bounces it, okay, it just flew really high. There you go. And it, see the same force he threw downward, applied upward. For Newton's third law, every force applied has an equal and opposite reaction. So I'm going to be demonstrating this with a chair. When my brother applies force against the step, even though it's going that way against the step, he's going to be pushed that way away from it. So there we go. Final example of Newton's third law, I'm going to be showing that I'm going to be demonstrating it by kicking the house, and when I kick the house, I'm going to be applying a force against the house, and then the house will be resisting it, and so I will be propelled backwards. So. Okay, so now I've demonstrated all 3 of Newton's laws, and I hope you understand them.